Hello, today I'm going to go over this worksheet, Calculating Seafloor Spreading. So it gives a little description here about what seafloor spreading is and some of the evidence of how we know this. And what you see on this map is you see the ocean floor of the Atlantic Ocean. So here's the east coast of the United States, here's Europe and Africa, and the mid-Atlantic ridge runs right through the middle of the Atlantic Ocean. And this line here, this red line, is showing you the newest ocean floor. It was created recently, so we say it's from the present, even if it's a couple 100,000 years old. This is all new material that magma has created, rising up and breaking through the cracks of the crust. As you move away in either direction, you get increasingly older rock because the seafloor is pulling apart slowly, slowly, slowly. So the oldest rock is the furthest away from this line, this red line that represents the mid-Atlantic ridge. And then we get another line out here, this other blue line, which is the same age as the blue line over here. The numbers up here are showing you how old that rock is in millions of years. So 40 million years old, 80 million years old, 110 million years old, so on and so forth. So what we're going to do is we're going to do a little bit of measuring using this map, and we're going to calculate the rate of speed that the plates have been moving over the last 280 million years. Okay, so let's take a look at the next page. This is where we're doing our calculations, and we're going to start with the basic rate of speed formula, which equals distance divided by time. It's kind of like in a car, right? If you're going 60 miles per hour, your distance is 60 miles, and the time is an hour, 60 miles per hour. So we're going to calculate that for the ocean floor. So what we need first is to figure out a distance, and it says we're going to calculate it for each one of these lines on the map, which is representing our time. All right, so the first one is 40 million years ago. That is this orange line, this 40. And what we need to do to figure out that distance is how far away is that orange line from the red line. So you'll need either a ruler or just something to help you measure this scale down here. This scale has a line, black line, that's 500 miles. So I'm going to use a ruler. It doesn't have to be a ruler, just something that you can estimate that length. And I look at this. Okay, that's 500 miles, goes out to about 2 centimeters. Well, I'm going to measure from the red line to the orange line, and that looks like about 1.5 centimeters. So 1.5 centimeters on this scale, I'm estimating it at about 350 miles. Okay. So my distance, 350 miles, that's how far it's traveled. And then we need the time. Well, this is the time right here, 40 million years ago. So we're writing 40 million. And that's going to give us our rate of speed. So let's do that calculation. 350 divided by 40 million equals this number with lots of zeros. 0.12345. 875, and that is miles per year. So that's the rate. That's how many miles that the plates move in 1 year. A very small amount, so it adds up over time, but in the course of a year, you don't even notice it. Do the exact same things for these. So at the 80 million year mark, you're going to estimate the distance from the present to the 80 million. And that's going to be about 700 miles, okay? So you'll finish up the calculations for these. Then we have some other calculations. All I've done is rearranged the formula that we used up here. And this one, we're going to calculate distance. So it says calculate the distance if you have an average rate of speed of 0.000094 miles per year. And to do that, I take my rate times my time. So here's my rate. That's going to be the same for all of these. 1, 2, 3, 4, 5, 9, 4. Multiply that by my time. Well, remember, my time is 5 million years in this case. So let's figure this one out. 0.0000094 times 5 million equals 47. So that is a distance of 47 miles. So that's how many miles it traveled in 5 million years. You'll do the exact same thing for the next two, and it's going to give you the distance that it's traveled in that amount of time. Now we rearranged it again. We're going to figure out time, and we have distance divided by rate. So calculate the time if the average rate of speed is 0.0004 or 12 miles per year. So first thing I need is the distance. Well, I know it's going to be 5 miles. So how long did it take to go 5 miles? We're going to divide that by our rate, which is here. 412. And that will give us how long it took to go 5 miles. 5 divided by 0.000012 equals, so for the seafloor to move 5 miles, it took 416,667 years to go 5 miles. And you'll do the same thing for these ones. So let me know if you need any help. Hope this helps.